Hi, this is Mary. Once again, I had another topic in advanced algebra which is combination. Don't skip, just watch this video. Combination is a group of objects where order does not matter. This is one of the formula in computing combination. Combination of 6 of 8 objects is equal to n factorial over the difference of n and k factorial multiplied to k factorial, wherein n is the collection of objects, k or r is the number of possible combinations. Here's another formula in computing problems in combination through the use of formula in permutation. As we recall the formula in permutation, permutation of n taken r over r factorial, wherein the permutation of n taken r is equal to n factorial over the difference of n and r factorial. It can also express in this way: combination parenthesis, the value of n is on the upper and the value of r is on the lower. Suppose there are 20 students in a class and choose 5 of them to go to a math challenge. Regardless of the order you name the students, they will represent the same group. Those 5 students represents a combination of 5 of the 20 students in the class. So n is equal to 20 students and r is a group of 5 students. Another example is, in how many ways can a committee of 3 be formed from a group of 12? Combination of 3 committee from a group of 12 is equal to 12 factorial over the difference of 12 and 3 factorial multiplied to 3 factorial. So the 12 factorial is equal to 1320 over 3 factorial, which is 6, and that is equal to 220. Another example is, what is the combination of 3 marbles which are drawn at random from a box containing 3 blue and 5 green marbles? The collection of objects, or n, is equal to blue marbles and 5 green marbles, and a total of 8 marbles. The problem is asking for a combination of 3 marbles which are drawn at random, so the r is 3. We come up to the combination of 3 of 8 objects, which is equal to 8 factorial over the difference of 8 and 3 factorial multiplied to 3 factorial. 8 factorial is equal to 336, and the difference of 8 and 3 factorial multiplied to 3 factorial is equal to 6, which is equal to 56. There is a follow-up questions from the problem. How many different rows would contain only blue marbles? The collection of object is 3 blue marbles, and the problem is asking what is the combination of 3 marbles. So the combination of 3 objects, which is equal to 3 factorial over the difference of 3 and 3 factorial multiplied to 3 factorial. 3 factorial is equal to 6 over the difference of 3 factorial and multiplied to 3 factorial is equal to 6, so which is equal to 1. So we conclude that when n is equal to r, the combination is always 1. Binomial coefficient. So why this binomial coefficient is correlated to combination? Because binomial coefficient can be expressed using combination. So parenthesis n r close parenthesis is the number of ways of picking r unordered outcomes from the n possibilities, also known as the combination or combinatorial number, n taken r at a time. Let's have a brief history about binomial coefficient. In the 12th century, there was an Indian mathematician named Bhaskara Acharya whose work included descriptions of the integer coefficients. The study of these coefficients relied heavily on the combinatorics. These are the example of binomial coefficient. Parenthesis x minus 2, close parenthesis raised to 3, parenthesis 2x minus 3y, close parenthesis raised to 4, parenthesis x squared minus 2, close parenthesis raised to 5, parenthesis x squared minus 5y squared, close parenthesis raised to 5. These are some of the example. We have a lot. Why they are called binomial coefficient? Because the term binomial, there are two terms inside the parentheses. Like for example, in x minus 2, x is the first term and 2 is the second term. Other than that, the other example is 2x minus 3y. 2x is the first term and 3y is the second term. But the binomial are raised to exponents. So that is more than 2, or the exponent is more than 2. There are ways on how to solve this. Using mnemonics or the FOIL method, you have to multiply the outsides, insides, and last. Other way of solving this is through the use of Pascal triangle. Pascal's triangle is a triangular array of the binomial coefficients. How do we use this Pascal triangle, and how do we construct this Pascal triangle? The top and the first layer of the two sides of the triangle is surrounded by number 1. You will add the right and left below numbers of the above number. Just by adding the succeeding right and left numbers, you can complete the triangle. How do we locate the exponent of the binomial? Look at the second digit of the triangle that you've constructed, and if the number is the same as the number of the exponent of the binomial, it will become the numerical coefficients of the polynomials. So like for this example, x minus 2 raised to 3, the exponent is 3. Look at the constructed Pascal triangle on the right below. Locate the exponent 3 to the second digit of the every layer going down. In the triangle, the exponent is located in the fourth layer. So the numerical coefficients of exponent 3 are 1, 3, 3, 1. Distribute these four numerical coefficients. The operation is addition. Then the binomial is x minus 2. The first term is x and the second term is negative 2. By distributing this binomial beside the four numerical coefficients that we've got in your constructed Pascal triangle, the terms in binomial is enclosed by parentheses and treat as ordinary variable and number. This variable and number are raised to exponents. Since the binomial is raised into exponent 3, the exponent of the variable is raised to the highest degree, which is 3, and the exponent of the number is raised to lowest degree, which is 0. The degree of the exponent of variable is decreasing while the degree of the exponent of the number is increasing. And as you observe, when you add the exponents of the variable and number is always 3 for this example. We come up with the polynomials 1 times x cubed times negative 2 raised to 0 plus 3 times x squared times x times negative 2 raised to 1 plus 3 times x raised to 1 times negative 2 raised to 2 plus 3 times x raised to 0 times negative 2 raised to 3. When we reduce these expressions, 1 times x cubed is equal to x cubed. Negative 2 raised to 0 is 1. So x cubed times 1 is x cubed plus 3 times x squared is equal to 3x squared times negative 2, which is negative 6x squared, plus 3 times x raised to 1, which is 3x. Negative 2 raised to 2 is equal to 4. So 3x times 4 is equal to 12x plus 3 times x raised to 0 is equal to 1 times negative 2 raised to 3 is equal to 8. So which is 8. So the polynomials is x squared minus 6x squared plus 12x plus 8. For your exercises, expand and reduce the following binomial coefficients using Pascal triangle.
I hope you like this video. If you haven't subscribed to my channel, don't forget to watch all of my videos and also like, share, subscribe, and click the notification bell down below. See you next week.